Progress channel. So today we'll be solving check if the number is Armstrong. So the problem statement states that you are given an integer n. You need to check whether it is an Armstrong number or not. Return true if it is an Armstrong number, otherwise return false. An Armstrong number is a number which is equal to the sum of the digits of the number raised to the power of number of digits. For example, 153. So the output is true because the number of digits in 153 is 3 and 1 power 3 plus 5 power 3 plus 3 power 3 equals the 153, the same number again. So this is an Armstrong number. So let's try to solve it. So there are two points, important bottleneck points that you have to remember here while solving this problem. So when I write the program, I'll go through it. Let's keep track of all the required variables first of all. So I will be modifying n in the process, so I'll keep track of the original number. So my original number will be n, and I need to keep a track. I need to count the number of digits first of all, so that I can raise it to the power of that digit for individual numbers. So I need one more variable called digit count, number of digits count, which I will be setting it to 0 as of now. And to separate out individual numbers, I need something called remainder, which I'll be setting it to 0. And I have to sum up all the numbers after raising it to power. So I need another variable sum, which will be setting it to 0 as of now. So there is an important point in math library where without doing any operation you can directly get the digits count. So that is digits count equals I'm passing this with integer data type because there is a function in math library that is math dot log 10 of our input plus 1 will give us the number of digits in a number. So this is an important formula that you guys should remember. Now next we have the digits count, I mean the power to which the individual digits has to be raised. So I will start a while loop while my n is greater than 0. First I'll calculate the remainder. Remainder will be n modulus 10. So I'll get the last digit. Now I have to sum up. I will keep track of the sum. Sum will be sum plus integer data parsing 2, because I'll be using another math function, that is math dot power of the remainder raised to the power of digits count. So each individual digit I'll raise it to digits count power and add it to the sum, and I will make sure to reduce the number by 10. Now if now checking for the Armstrong number, if my original number is equal to the sum that I've calculated just now, we'll say that it's an Armstrong number, will return true. For any other condition, for all the other condition, I'll return false. This is the logic to check for Armstrong number. Guys, these two formulas you should remember. Math.log 10 of the input will give us the number of digits in the number, and the to raise the individual number to the power of the digits count. These two are the main important points while solving this Armstrong problem. Let's run this program. So the test cases have passed. Let me submit the code. So all the test cases have passed. Thank you, friends.